This problem says to find the critical numbers of the function f of x is equal to negative 12x to the power of 5 minus 15x to the power of 4 plus 30x to the power of 3 plus 1 and classify them. And that classification needs to either be a local max, a local min, or neither. So the first thing that we need to do to find the critical numbers is to take the derivative. The derivative, using the power rule, would be equal to negative 60x to the power of 4 minus 15 times 4 is 60 as well, x to the power of 3 plus 3 times 80 would be 240 x to the power of 2, and then the derivative of 1 would go to 0. So now let's set this derivative equal to 0. And also we need to factor out any common factor. Let's take out a negative 60, and we have at least an x squared in every term, so let's take that out as well. So the first term would go to x squared, the next term would go to x. Since this is a positive, if we take out a negative, it would change signs and turn negative. And 240 divided by 60 is 4. So this would be 4 is equal to 0. So now we need to see if we can continue factoring. We're looking for two numbers that multiply to give us negative 4 and add to give us positive 1. And I don't think that there's anything that we can factor. So instead, let's use the quadratic formula. But first, we know that one of our solutions will need to be negative 60x squared will be equal to 0. And then the other will be the x squared plus x minus 4 is equal to 0. So first, we can solve this equation by dividing both sides by negative 60 to get x squared is equal to 0, and then square rooting both sides to get x is equal to 0. So that's one of our critical numbers, is x is equal to 0. To use the quadratic formula to solve this quadratic, since it's unfactorable, would be the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So plugging that in would be negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 4 all over 2 times 1, which is negative 1 plus or minus 1 squared would be 1, and then negative 4 times 1 times negative 4 would be positive 16. So this would be 1 plus 16, which is 17 over 2. And we just need to find these to 5 decimal places. So if we do negative 1 plus the square root of 17 and divide that by 2, I get that to be 1.561. Oop, that was a 6. Hold on. 561,553. Or negative 1 minus square root 17 divided by 2 is negative 2.561,553. So these are our numbers. If we round them to 5 decimal places, that would be to this 5 and to this 5. And those would be our 3 critical points. But we need to classify them as a local max, a local min, or neither. So to do that, I'll draw a little number line and write my critical points. So starting from the smaller number on the left would be my negative 2.56155, and then my middle number would be 0, and my larger number would be 1.56155. So now to figure out whether it's a local max or a local min, we need to figure out what's happening in between these spaces. So let's choose a test point. Let's say, I'll change the color to show that we're doing a test point. Let's do a test point over here of -3. Let's do a test point here of -2, and here of 1, here of 2. So plugging in all of these numbers into my derivative will tell me whether my function is increasing or decreasing. So let me give myself a little more space. And if I find my derivative at -3, if I plug in -3 into my function, I get -60 times -3 to the power of 4 minus 60 times -3 to the power of 3 plus 240 times -3 to the power of 2. Okay, so we don't really need to know what this number is, we just need to know if it's positive or negative. This first number would be -60 times 3 to the power of 4, which is -4,860. And then here we have -60 times -3 to the power of 3, which is a positive 1,620. And then this number is going to be a positive, so we have to figure out if it's going to make it positive or negative. So 240 times 9 is plus 2,160. So adding that up, I can't really tell by just looking at it, so adding all of those up together gives me -1,080. So this derivative would be negative in this region, which means it's decreasing. The function is going to be decreasing until it hits this point, this critical point. So now we need to figure out what happens between -2.56155 and 0. So plugging in -2 into my derivative, I get f prime of -2 is equal to -60 times -2 to the power of 4 minus 60 times -2 to the power of 3 plus 240 times -2 to the power of 2. So simplifying all of that, -60 times -2 to the power of 4 minus 60 times -2 to the power of 3 plus 240, just plugging this whole thing into my calculator this time to save a bit of time. I get that to be a positive 480. So that means that the function will be increasing in this region. So when you change from decreasing to increasing at a critical point, this is a local min. So that tells us that our critical point of the -2.56 is classified as a local min. Now let's plug in 1. I need to give myself a little bit more space again. So f prime of positive 1 is -60 times 1 to the power of 4 minus 60 times 1 to the power of 3 plus 240 times 1 to the power of 2. So that, plugging that into my calculator, is positive 120. So the derivative is positive between 0 and 1.56155. So it's going to be increasing until it reaches 0, and then it continues increasing. So because it doesn't change from increasing to decreasing or decreasing to increasing, at 0 this is going to be neither. F at 0, or when x is equal to 0, this is neither a max or a min, because it has to change from increasing to decreasing or decreasing to increasing in order to be a min or a max. So now for the final test point, I chose 2. And if I plug that in, I get negative 60 times 2 to the power of 4 minus negative 60 times 2 to the power of 3 plus 240 times 2 to the power of 2. I'm plugging that into my calculator. I get that to be negative 480. So it is negative here, so it goes from increasing to the left of this critical point to decreasing. So when it changes from increasing to decreasing, this would be a local max. So we have our 1.56155 is a local max. And there we go. We have 3 critical points, the negative 2 number, the 0 number, and the 1.56 number. And we have 3 different classifications, a local min, neither, and a local max. So I hope this question was helpful for you. If it was, please subscribe to my channel and share with anyone who you think might find this information useful. Thank you.